Hello, welcome to the next one, which is adding and subtracting radicals. Now, the idea behind adding and subtracting radicals is really simple. In fact, I could go ahead and write it. I'll tell you what I want. We'll get there. But before we get there, I want you to think about something, and that is what we talked about when we said like terms. And what are like terms? Basically, it was the same variable to the same power, right? So like terms being same variable to the same power means, well, what did it mean? Those were the only things we could add or subtract. So for instance, I can add 3x plus 4x and get 7x, okay? I'm just adding the numbers in front, remember? We don't do anything with the x's. And the way you can think about it is I have 3 of these, and now I have 4 more of those. So altogether, I have 7 of those. And that may be a real non-technical way of thinking about it, but that's exactly what it means. All right. Now, what if we had this, 2x plus 5y minus 3x? Well, that was 2x minus 3x. 2 minus 3 is negative 1, or negative x, plus 5y. Okay? I could not add these two together because they're different terms. Now, when we add radicals, we have a similar idea of like terms, and let's call it like radicals. All right? So to add or subtract, and I honestly have never used this term before, this video, but I like it. We need like radicals. In other words, our radicals have to be exactly the same for us to add them. All right, example. 3 square root of 2 plus 5 square root of 2. How do you add these? Well, first of all, are the radicals exactly the same? Yes, they are. They're both the square root of 2. So now the way we add those is we're going to add the numbers in front just like we did with the variables. 3 of these plus 5 of these is now 8 of those. All right. What if I had, 6 times the cube root of 13 minus 8 times the cube root of 13. Again, it's the same root. They're both cube root of 13. So 6 minus 8, well, that's negative 2. And then the root stays the same. The radical stays the same. What if we had the square root of 3 minus 4 times the square root of 2? I can't do anything with that. I can't really add or subtract these. I'll just write it here, can't subtract. And the reason I can't subtract those is because they're different radicals. This is the square root of 3, that's the square root of 2. Another thing that would be an example of things we can't add would be if I had different radicals. So for instance, if I had 4 times the cube root of 11 minus 2 square root of 11, I can't add or subtract those either because this is a cube root and that is a square root, and these are different roots. Different roots. Or we'll say radicals. Okay, I can't add or subtract those either. So basically the idea of adding and subtracting radicals is if we have the same root and the same number under the root, we can add and subtract the numbers out front. All right. So what I want to look at is, let's just look at another example. Let's look at the square root of 20 plus 2 times the square root of 45. Now, according to everything I've told you so far, we cannot add or subtract these, because although we do have 2 square roots, the numbers under those are going to be different. So here's what we're going to do, though. We're going to simplify first. What do I mean by that? I mean, I'm going to look at the square root of 20, okay, and I'm going to do that factor tree method here for a while. I'll probably do that most of today. 20 is 2 times 10, which is 2 times 5. I'm talking about a square root, so I've got a pair of 2's there. I can write this as the 2 comes out front, square root of 5, all right, plus 2 times. All right, this 2 comes from that 2 being right there. And now I'm going to try to write the square root of 45 a different way. All right, so 45. I know that's 5 times 9, 3 times 3. Okay, so that means the square root of 45 can be rewritten as 3 times the square root of 5. Now I'm going to fix that because that looks a little bit like a cube root. And I want to make it obvious that that 3 is out front. All right, so now this is 2 times the square root of 5 plus 2 times 3, so this will be 6 square root of 5. And now I've simplified my radicals. I've multiplied anything that I need to multiply there. And now I can actually add, and I get 8 times the square root of 5. And in general, this is going to be how these problems work. We're going to reduce the radicals first. We're going to add and subtract the numbers in front. Okay? And once we reduce them, the number under the radical never changes again. So 1, simplify radicals. Number 2, we're going to add or subtract as we're told to do. And then 3, the number under the radical does not change after being simplified. All right. That's our basic way we're going to do these problems. So what's different? Well, this is just putting a lot of things together that we've already known. We know how to simplify radicals. We've talked about that. Adding and subtracting, that's a little new, but now we have this idea that we have to have the same radical, and then we add the numbers out front. Okay. And then the number under the radical is never going to change after we simplify. So notice, I had square root of 5 after I simplified, and that never changed again. So that's how this is going to work. So now we've got the basic idea done here. All we need to do is work a few examples and see how they work. And that's what we're going to do. All right, 5 square root of 48 plus the square root of 27 minus 3 square root of 3. Now you might be thinking, oh, now you've got 3 things in there. And there'll be several problems where you have 3, but in most of these, there's going to be one of the radicals that doesn't simplify. So it'll kind of actually give you a hint of where you're going. All right, first thing is 48. So I'm going to come over here. 48, that's 2 times 24, which is 2 times 12, 2 times 6, 2 times 3. All right, I'm talking about square roots. So I've got a pair of 2's, and then I've got another pair of 2's. So I can write the square root of 48 as 2 times 2, which is 4, square root of 3, plus. Now I've got to look at the square root of 27. Okay, 27, that's 3 times 9, which is 3 times 3. There's a pair of 3's right there. So this can be written as 3 times the square root of this 3, because that's left over. And then square root of 3 is just the square root of 3. You can't do anything with that. Okay. 5 times 4 is 20, square root of 3. All right, 20 plus 3 is 23, minus 3 is 20 times the square root of 3. That's our answer. All right, so adding and subtracting radicals really is this. Simplify your radicals, add and subtract the numbers out front, make sure your radical doesn't change again. The one thing people miss on this more than anything else is that they will do the square root of 48 is 4 square roots of 3, and they will forget about this 5. Okay, that's why I always write 5 times, and now, what is the square root of 48? It is 4 times the square root of 3. Next step, I'm going to multiply, and then I'm going to add. As always, I'm not doing every example I have on the paper. If you want to look, and occasionally I change the examples up, like for instance, that example that I just did, it's a little different than what's on the paper. So if you're looking at the paper, you will notice the answer is a little different, but that's because the problem was different. All right, let's do one that looks really hard and really obnoxiously complicated, and do that. All right, 6z square root 48z to the third minus 27z to the fifth, and that is under the square root. All right. This is going to take us a minute. All right, because this is going to take us back to that last section where we had to simplify things that looked like this, and that wasn't necessarily the easiest thing we'd ever done. So I'm going to actually just do this a little bit. I'm going to kind of break it out into pieces. So the first thing I'm going to do is still simplify, and I'm going to work on this 48z to the third. All right, so the square root of 48z to the third, I can write 48 as 16 times 3. And remember, you could do factor tree with this also. I'm just doing it this way. All right, can I take the square root of z to the third? No, but I can take the square root of z squared. And if I put z squared here, I have to put z over there just to take up for the stuff that I'm leaving out. And now the square root of 16z squared is 4z. Cube root 3z stays under there. All right, so that means I have this, 6z multiplied by 4z square root of 3z. All right. Because again, this is just a simpler, simplified way of writing that. It has the smallest thing under the radical. All right. Now, let's look at 27z to the fifth. This number right there. All right. The square root of 27z to the fifth. Okay. I can write 27 as 9 times 3. 9 is a perfect square that divides 27. Okay, 9 times 3. And then I cannot take the root of z to the 5th, but we've done this several times now. Z to the 4th I can take the square root of, so I have to have z to the 1st over there because those exponents have to add up to 5. Now I'm going to take the root 3z squared square root of 3z. 3z squared square root of 3z. All right, so that's the first thing. That was the hardest part of the problem, was simplifying those two radicals. Now that they're simplified, we need to multiply the 6z times the 4z, and that will give us 6 times 4 is 24. Z times z is z squared, square root of 3z, minus 3z squared, square root of 3z. All right, what is 24z squared minus 3z squared? Now, you might have wanted to say those z squareds are going to cancel out. We have to be careful, all right? Remember how subtracting variables work. This is actually going to be I have 24 z squareds. I'm taking away 3 of those z squareds. That means I have 21 of those left. All right, and that's one of the more complicated problems we will do, because we had to simplify 2 of these kind of complex radicals, and then once we did that, then we had to multiply and subtract. Right? And if we weren't careful and we didn't go step by step and we tried to just jump in and do it all at once, we definitely would have messed something up there. I know I would have. Now, some of you are probably smarter than me, and I mean that seriously. So maybe you could go through it, but I like to go through it step by step and just make sure that I'm getting things like I want them to be done. So that's going to be enough for this. That'll give you adding and subtracting, and that'll give you something to work on. The next thing we're going to do is going to be where we multiply and add and subtract. And it's really just the same thing. We're just going to multiply first. And we're going to talk about how do we multiply these radicals together. All right, so until next time.